All right, guys. Hey, let's grab. Hey, Eden, you need to grab your handouts. Grab everything you need. Why didn't you eat your breakfast during homeroom?
I came in late.
Let's go, Bella. Hey, Bella. Let's grab your worksheets and then let's start the warm-up for me, okay? Why are you coming in late? You ride the bus? So your bus is late all the time? No, I know the bus is not late all the time. Hey, let's go, guys. We got 5 minutes on the warm-up. All right? We probably don't even need 5 minutes. What's up, Chase? Let's get it going. Let's try to take, hopefully once you get started, you only take 3, but take a minute or 2 and get ready, and then let's get going. So David's not here? Please grab your worksheets. Please open up your binders. And somebody needs to start on the warm-up. Eden, we got to start on your warm-up. Breakfast is fantastic, but you need to start on your warm-up while you're eating, okay? You already know it? All right, so I'm coming to you then, okay? All right, good. Good. How was class yesterday, guys? Did we get something done?
Yeah.
Yes? We sure? So the one-step equations or the two-step equations, those are pretty okay for you guys? All right. I'm glad to hear it. How was the sub yesterday? She didn't, I'm sorry?
She's kind of sending back this last one from me.
Well, you should be doing your work.
You know, we were doing our work, but
Yeah, but they're just here to help facilitate things. They're not here to teach you guys, so that's what they're doing. You need to get a pencil out. You need to get your Chromebook out. Get everything ready first before you think of trying to eat that. Chase, where's your Chromebook? Why don't you get it open in case you need it, okay? Everybody, that should be one of the first things that we're doing every morning. Let's go, Kenny. So here we go, guys. I'll read it, and then we'll take a minute or two to figure it out. Does somebody else want to read it for me? Eden, you want to read it for me? Read it out loud. Come on. Read it loud so Kenny can hear. Let's go.
here are two diagrams. One represents 2 plus 5 equals 7. The other represents 5 times 2 equals 10. Which is which? Label the length of each diagram.
Okay. Good. So we have to find which is which. So take a minute. I think this is more of like you can see it and figure it out as opposed to writing a lot of it down. Because I guess there really isn't that much to write down here. Chanel, how are you looking on this? Okay. So Eden told me that he had it. Did everybody have enough time to look at it? Mariah, are we good? You're looking at your computer. Are you good? How about you, Chase? Kenya, how are you looking? What paper? That's okay. Don't worry about that right now. We're going to look at this new one. Bella, how are you looking? We okay? All right, Eden, tell us about it. Eden said he was going to volunteer to tell us about this. So one is 2 plus 5 equals 7, and the other is 5 times 2 equals 10. Which one is which, Eden?
So I think the first one is 5 times 2.
5 times 2? Okay, what's your reasoning behind that?
Because that is 5 2s.
5 twos, right? So there's 2, how many times? 5 times, right? Is that correct? So if we look all the way across here, how many times do we see it? 5 times, right? Right? He says there's 2 2 5 times. How about that one?
2 plus 5.
How much? Okay. So how much would this be right here? So that will be 7. That will be the 7. How about this one right here? 10. Okay, did everybody see what's going on? So take a look here. If we don't understand this, we're going to have trouble. We may have trouble later. So eyes up. Kenny, eyes up right here. So when it says, when we see this tape diagram, if something says 5 times, how many boxes do I need to draw? 5. I mean, that's pretty obvious, right? If it says 5 times, there's probably 5 boxes. And then it's saying 5 times what? 5 times what? 2. So that means 2, 5 different times. Do we see that? So the first number is how many times we're doing it, and 2 will be inside the box. Okay? Oh. Thumbs up, thumbs sideways, thumbs down, thumbs sideways. And this one is just what? Each box, this box represents how much, Chase? No, this one box. How much does it represent? How much does this box represent? So when I add this diagram together, what does it equal? 7. Okay? And we can do it right here. We can multiply it, or we can just add it 5 different times too. 2 plus 2 is 4, plus 4 is 6, plus 4 is 8, plus 4 is 10. Okay? So the tape diagram looks like we understand it? Okay. Hey, we're getting into tape diagrams today, so if you have some issues, let me know. Let's take a look at, this is going to be our learning target today. Hey, Kenny, can you read it for me? Okay, so there are 2 steps. It's not 1, it's going to be 2. And what are we using? Tape diagrams. So we're going to do it 2 ways. We're going to do it through tape diagrams, or we use algebra. So algebra was some of the stuff you guys did yesterday, or some of the stuff that we've done in the past, right? Where we solve for x. So that'll be the algebra part. We're going to use tape diagrams to try to figure that out. All right, everybody, we're on our handout now. You're on your handout. Kenny, where's yours? Did you get yours? Go grab. You know, once Kenny has a seat, you want to read it for me? Can you read it? We're going to do the one that says solving 2-step equations with tape diagrams. That's the one we're on right now. Eden, do you have yours out? You have to. Hey, you got to get it out. It's hard for us to do math if you don't have it out. Go ahead. Hey, Chanel's going to read it for us. Go ahead, Chanel.
30 flowers for volunteers in her club to hand out around school. She gave an equal number of flowers to 7 volunteers, and she hung up 9 flags. Create a tape diagram to describe this
Scenario.
and use the diagram to find how many flowers she gave to each of the 7 volunteers.
Hey guys, the important part that we pay attention here is because, is the word problem short? No. So the first challenge is understanding the word problem, right? If we don't understand the word problem, trying to solve it it's so difficult, okay? So we know how many volunteers does she have, or how many flowers does she have total?
30.
She has 30, okay? It says it right here. So let's look at the numbers. So it has 30 total, okay? She gave an equal number of flyers to how many volunteers? 7, okay? So she gave an equal number to 7 volunteers. So those are my key numbers. And then what's my other number that we're looking at? How many did she hang up? She did these herself. How many did she do herself?
9 flowers.
She did 9 by herself. Okay? Hey, Ms. Aria. So she did 9 by herself. So now it's saying create a tape diagram. Okay? So remember when we had that tape diagram, I'm going to just draw this box right here. And remember when we had that tape diagram, we just had something down here. And what did that equal? That was the what? This is going to be the What do we have in our warm-up? What was at the bottom? The total, right? What's our total? 30. So the total is going to be 30. Whatever all this equals, we're going to have 30. Are we okay with that? So now we have to see how we have to break those other two numbers down. 7 volunteers. So she gave flyers to 7 different people. Okay? Do we know how many she gave, Mariah, to each person? Yes or no? Well, it says, look, she gave an equal number of flyers to 7. Okay? So we don't know how many she gave, but we do know how many she hung up. How many she hung up?
9.
She hung up 9. So what I'm going to do is I'm going to make a little box right here, and I'm just going to write 9. Okay? Because of the 30, who hung those 9 up? May did, right? May hung up 9 of the 30. The rest of them we don't know. Now I got to break that up into how many different boxes do you think? Chase, how many boxes do you think I got to break that up into? 7 because what? Good. Because an equal number was given to how many? 7 different people, right? So let's take a look at this. 1, 2, 3, 4, 5, 6, 7. Did I just say 6, 7? Oh, my goodness. There we go. So look, does that make sense?
Yeah.
Now, do we know how many she gave him, Chase? Do we know how many each person got? No. So if I don't know how many each person got, what can I put in for that was given out? No, not a 9. I've already 9 what May handed out, right? May handed out 9. What do we know? If we have an unknown, what do we usually put for an unknown? You said it's an X, or what do we call an X? Or letter is the same thing. X. We call it a what? Very good. Very. X. That's 7. Okay? And remember all. Okay? Does this make look this is an equal number, equal amount, so I can represent them all X. Eden, you got it right, buddy. You got it right. Okay? We haven't done this yet, so if it's the first time doing it, we have to make sure that we have something to reference it back to. So these 7 people gave the equal amount. So let's add, remember we're talking about combining like terms. What does that mean, combining like terms? How many different terms do I have here? Well, no, I can say that, but what kind of term is this? It's just a what? Variable, which is the X, right? And I have just a number by itself is called a constant, okay? So can I add all these variables together? Can I? I can. So how many variables do we have here? We have 7, right? So let's take a look right here. If I have 9, we have 9 that they gave out, and then we have 7. We have to figure out what each one represents. Can somebody help me and then tell me how we're going to figure out what's going on right there? I'm going to let you think about it for a second. How do I figure out what the X represents? Anybody got an idea? Huh? There's 7 volunteers. Yes, that's correct. 1, 2, 3, 4, 5, 6, 7. How do I know how many each handed out? So they had to hang up the flyers, right? So May hung up 9, and 7 people hung up how many flyers? How do we figure that out? This I know is 9, right? I know that's just 9. How many X's do I have here? Right here. 1, 2, 3, 7 x's, right? Can I add this and this together? Well, all equals what? 30. So I'm going to put these like terms. So I'm going to add we said that's 7. Is that correct? Right? What does the total out to be? What is the total? 30. Now, do we see? He hung up, and 7 different people hung up. We don't know how many, but they hung up the same because amount. If we looked at it, we probably should be able to. Look, what do we have here? 9 plus 7x equals 30. Okay? Now, what's the first thing we have to do here? I got to put the x by itself. What do you got, Chase?
Don't you like cross the
You mean here? Straight down? Well, the main thing that we have to do is we have to isolate the x. How can I keep the x by itself? How do I get the x by itself? The first thing I need to do, anybody have an idea? If this is multiplication, the first thing I need to do is whatever's not touching the x, okay? Whatever's not touching the x is what I need to do first, okay? Is that positive or negative, Chanel? It's positive 9. So I need to find the inverse. So we're finding the inverse of positive 9. What's the inverse of positive 9, Mariah? Negative 9. So remember we did those 0 pairs, right? It's all coming together to what we've done before. I'm going to take this, and since that's a positive 9, I'm going to make that negative 9. Okay? Positive 9 and negative 9 equal what? 0. It's a 0 pair, right? Listen, and Chase, what you're talking about is once they drew this line down here, whatever you do on this side of the line, you have to do on this side of the line. Okay? So I subtracted 9 on this side of the line. So what do I have to do on this side of the line? Subtract what? Subtract 9. Okay? So I'm going to go ahead and subtract 9. Remember, we said that's a 0 pair. So did I touch this? So what do? I just drop that one straight down. Okay? Drop it straight down. Drop the equals down. What's 30 minus 9? Somebody help me with that. 30 minus 9, yes. 21? Good. 21? Yes, that's right, Mariah. Okay. Now we have to find inverse. See, we had a positive 9, so we did the opposite, minus 9. Now, what's going on with this x right here? What's going on with the 7 and the x? What operation is being used? What operation is being used? Remember when the letter is right next to the number, what are we doing? What operation is being used, Kenny? Is this addition? Is it subtraction? Is it multiplication or is it division? It's multiplication, right? So like I did the inverse here, I got to do the inverse here. So I'm multiplying by 7. Right? Chanel said we're multiplying. What's the opposite of multiplying by 7, Eden? Multiplying. What's the opposite of multiplying? Division. So instead of multiplying by 7, what am I going to divide by what? Divide by 7. Okay? So I'm going to take this and I'm going to divide this by 7. Okay? And we just said it. Kenny, if I do this on this side of the line, what do I have to do over here? So what's the same thing? Tell me what the same thing is. Divided by 7. Okay, good. Okay? The same number divided by the same number. A number divided by itself is always what? 1 over 1, 2 over 2, 3 over 3, 4 over 4. That always equals what? What did you say, Kenny? Huh? Hey, if you're not sure, you could punch in your calculator real quick, guys. Right? Any number divided by itself is what? Chanel, what is it? What is it, Mariah? 1. Now, if we can't figure this out, we're going to have trouble. Because Almost all of these is going to be like this, or a lot of these questions are going to be like this. All right, so that's one. So do I have to put 1x, guys? Or can I just put, what do I need to do? Do I have to put the 1x? I can just leave it as what? Chanel. I could just leave it as x. Okay? Somebody help me right here. 21 divided by 7. 3, you said? Yes. So there's our answer right there. What does x equal? 3. So what does that mean? Tell me what it means now. No. 7 people did what? Try one more time. Each of the 7 people did what? They hung up how many flyers? 3. So let's take a look. We're going to go back over here now. So we said that x is 3, right? Put a 3 here, a 3 here, a 3 here for all of these numbers. For all of these. If our answer we're at the 9, 3, 3, 3, 3, 3, 3, 3, and what number should I get, Mariah? If I add all these numbers right here up, what number should I get? No, I don't want the end. Look right here. What number should I get? 30. That's the total of all these boxes equals what? 30. Can somebody add that for me and make sure that's correct? Let me know after somebody's added it for me to make sure that's right. Is it right, Kenny? Okay. You check it too? Is it right? Okay. So this means this, guys. May hung up 9 flyers, and 7 different people hung up 3 flyers each. And what was the total hung up, Chase? 30. Okay? Any questions? So we could do it 2 different ways. We can figure out 2 different ways. Like this helps us visualize it. So you can see it a little bit better here. And once you get really good at that, you might just be able to come right here and do it algebraically. Bella, question? You got a question? Are you okay? How about you? We're okay? Everyone has it written down? Okay. Good? All right. Here we go, guys. Now, sometimes when we're not this is the reason why word problems get hard, guys, because sometimes it's hard to concentrate through the whole problem. Look how long that one is. So we got to concentrate. Can somebody read that one? Mariah, can you read it for us? So it's the same thing. When Mariah's reading, we're going to have to concentrate to figure out what do we need to figure out, right? We've got to see what we need to try to do. Thank you, Mariah. So let's look at the key numbers, the key words, and then figure out how we're going to set this up. Okay? Bella, you want to give me a key number? What's a number that you think we maybe need to circle? Take a look. What's the first number that we might look at? What we got? 50. Okay. So 50 is going to be, 50 is going to be 1. You got another number that we have to look at, or a key word? She got 5 flyers to the first person. So one person got 5, right? The first person got 5. What else, Chase? Keep going. 18 what? Second volume, 18, right? Anything else, Chase? That divided among how many people? Keep reading through. Divided the remaining flyers equally among the 3 remaining volunteers. Okay, so 3. Okay? So, hey guys, now what I want you to do is I'm going to draw the tape diagram, right? I'm going to just draw it out here just like this. And what I would like you to do is tell me how many boxes are going to be in there. Look at the information and say, Mr. Park, there needs to be 1 box. Is it just 1 box? Because the total is, what's the total, guys? The total is what? The total is 50, right? The total is 50. So is it just 1 box? Am I just drawing a 50 here? Is that correct? No. I got to break it up, right? So look at it and then see how many boxes we have to break that up into. Somebody help me out with that. Now, this is how we have to work word problems out, guys. We have to figure out what needs to be done, because if you can't do that, these word problems will get difficult. Who's got it? Nobody? What do you think, Chanel? You got an idea? I see you're starting your boxes. There's probably too many boxes. Kidding. What do you got, Bella? Don't hide it with your hands, girl. You trying to hide it? No? Let's see. We can't, guys, listen. You can't just start to draw boxes. We have to figure out how many, right? I know one person. Look, these people. Think of their, Kenny. Hey, eyes up. Right? Or I'm sorry, it's a number of volunteers. Right? It's a number of volunteers handing out flyers. Right? So a volunteer is going to hand out X number of flyers. How many people are handing out flyers? I have one right here. Is that right? Somebody's going to hand out 5. So I got 1. Maybe I'll do it. I got. How about this person? Is that person handing out 1? Mariah? Is this person handing out flyers? Yes or no? Look, back up here, Mariah. I have one person here handing out how many flyers? I have one person here handing out how many? So how many do we have so far? We have 2. How many more divided the remaining flyers equally among 3 remaining volunteers? How many more people are there? 3. 3. Right? So I could break this up. Let me do this. So the last, I'm going to do one this size. We'll do one a little bit bigger. And then the last 3, it says it's equal. So I'm going to try to make them equal. 1, 2, 3. We'll just leave it like that. Okay? How many did the first person hand out? 5. Right? 5. So the first person handed out 5. How many did the second person hand out? Chase. The second person handed out 18, right? How many did the third, fourth, and fifth person hand out? Eden, eyes up, buddy. How many divided the remaining flyers equally among the 3 remaining volunteers? How many did they hand out? The 3 people, how many did each one hand out? Mm-hmm. Which one do you want?
Kids, find how many flyers. Do we know how many she passed out to the next story?
Yes, we just talked about that, right? So how many, each person is a x, right? So we're going to write it over here. We're going to figure it out algebraically again. You ready, Eden? Eden, how many x's do I have over here? So I'm going to write over here 3, what? 3x. Eden, Eden, this is yours right here. Am I going to add the 18 or am I subtracting the 18? All of these added together equals this, right? This plus this plus this plus this plus this equals what? 50. So am I going to add the 18 to the 3x or subtract the 18? I'm going to add. How about here? What am I going to do with this 5? Am I adding or subtracting? I'm going to add, right? All what's the total, Chanel? What's it equal? No. What are all these equal to? That's what I mean, 50, right? So we have 50 right here. What's the first step that I'm going to do right there, Mariah? What do you think the first step is? Remember we were talking about the small Cokes and the large Cokes and things like that, right? What do you think I'm going to do? Huh? Combine what? Different numbers together or combine like terms, expressions like terms. What's the same over here? I'm going to draw this with Chase said he likes this, right? Chase, you like that? Okay. So what am I going to add first now, Mariah? I don't want to touch this side right now because I'm trying to get everything off of this side. I want everything off of this side, and I just want what by itself? The x. So I want to work on this side. What am I going to do on that side? Can I add 3x and 18? What numbers can I add? What can I add here together and it'll be okay? 18 plus 8. Mm-hmm. What's 18 plus 8? Somebody help me. Okay, good. So, oh yes, I'm sorry. Thank you. Thank you. Okay. So we got 3x. I'm just going to drop that down. Plus 23. Right? And I'm just going to keep it going. Equals 50. What do we do next? 0 pairs. The additive inverse. Think of that when we decide what we're doing next. Who can help me? Nobody? Somebody can help me. Hey, look at the previous problem. Look at the previous problem, and this we're doing something similar to the previous problem. What is our next step? No, Mr. Parker is going to wait until somebody gives me the right answer. What is our first step that we're going to do right here now? Hey, let me remember, I want this by itself, right? I want this by itself first, and then I want to get the x by itself. Oh, I'm going to drop it down like you said, but then what am I doing? Am I going to erase it? You mean just erase it? Get out of here? I got to drop it down like what, Chase?
Don't think of it as drop down. What you need to be thinking right now is inverse operation. You've got to undo all the math that has happened to that x. Everything that's happened to the x has to be undone. We're doing undoing the math. Inverse operation.
So that's what we were just saying. Inverse, 0 pairs. Think about it. I mean, that's the example that we're just trying to give. What do we need to figure out here? I need to get rid of what? I need to get rid of what? I just circled it, guys. What do I need to get rid of? Positive 23. How do I get rid of positive 23? How do I get rid of positive 23? 0 pairs. Additive inverse. Inverse operation. What is the opposite of that, guys? What's the opposite? Negative what? So instead of adding 23, what am I doing, Kenny? Subtracting 23. Okay? Everybody see that? Guys, listen, if this is hard, we got to figure this part out. Because a lot of this is just not math. I'm just thinking, how do I put it by itself? Okay? And our problem right now is not the math part, it's what do I need to do to put it by itself? Right? I'm trying to get that x, I got to do the plus or minus right here first. So minus 23. If I do it on one side, Chase, what did you say? To the other side of the line. Okay? So those cancel out because they're 0. I'm going to drop this down like Chase was saying earlier. 3x equals 3. 50 minus 23.
Everybody's calculator, click on it. Come on. 50 minus 23, let's go.
27? Now we got to figure it out again. What do I do next? I got to get the x by itself. Can somebody look at the previous problem or look at this problem and tell me how I get that x by itself? Inverse operations. What's going on right here? What's going on with this x? It's being what by 3? Added, subtracted, multiplied, or divided? Huh? Multiplied. If it's, guys, listen, if the x is next to the number, it's being multiplied. So it's 3 times x. So what's the inverse of multiplying by 3? Yes, Kenny? Well, so what's it? Well, let's do this. What's the inverse of multiplying by 3? The opposite of dividing by 3, multiplying by 3. Dividing by what? Dividing by 3. That's how I get the x by itself, guys. So remember, 3 over 3 is what? What's 3 over 3? 3 over 3 is what? 1. Okay? So if I do it on this side, Chase said I have to do it on the other. So those cancel out. X equals 27 divided by 3. Didn't you just find it? What did you say it was? Huh? 27 divided by 3. 9.
Just a comment. Maybe, from what you just did, I could tell that you know what's going on. You actually jumped ahead a little step. You jumped ahead and you immediately saw you've got to divide 27 by 3. That's awesome that you're already thinking like that and you get it. But you know what? I've been doing this for 22 years. How many papers do you think I've graded? Like hundreds of thousands at this point in time. And guess what I see? When kids start working over here, Kenny, this is for you, man. Come here, everybody. When you work here before you do this, I see kids make a lot of mistakes. When it's a one-step problem, you're like, come on, I got this in this area. You probably can. But you're going to have 2 and 3 and 4 and 5-step problems. And if you jump over here and work before you start here, you'll make mistakes. Here's what you need to be thinking. You're always looking at your x. Hello, ladies. You're always looking at the x first. And you're trying to undo the math around the x. Work here, then jump and balance. Work here first, then jump and balance. Don't jump here first and then go. And Sarah, come on. But I promise you 4 steps. And if you're in the habit of working over here first, you will make mistakes. So train your brain right now to think, I got to isolate the variable. Get the x alone. Then get the x alone. So you got to thumbs up if you hear what I'm saying, you get it.
Hands out.
And undoing the math around it. Okay?
What's the, Mariah, what's the x equal? Mariah, what does x equal? X says x equals 3? X equals 9. Put for this x. X equals 9. So this one's going to be a 9. What would this one be? 9. So if my math is correct, I can add a 5, 18, 9, 9, 9, and what should that equal, Mariah? No, what should it equal? I didn't say what does it equal. What should it equal? What's the total of all these? It's 50, right? It should be 50. Can everybody add that up and make sure that we have 50? $50? So then we're probably right. So, hey, bringing it back around, Chase, let's take a look right here now. One person handed out how many flyers? 5. One person handed out how many? 18. And 3 people had said it's equal. Divided remaining flyers equally among 3 people. So the 3 people equally, 9, 9. It's the same? Yes, it's equal, right? So 3 people each handed out 9 flyers. We okay? Right. Let's see if we can do this last one. This one has one more layer to it. Okay? It says to thank her 5 volunteers. So how many people do we know there were? 5 volunteers, right? May gave each of them the same number of stickers. Do we know how many stickers she gave? Do we know how many stickers? The same number. Do we know how many stickers there are?
30.
If I gave you guys the same number, but Miss Aria didn't get them, does she know how many I gave you? If I gave some and I gave her the same number, does Aria know? No. So from Miss Aria's perspective, what would how many did I give them? We don't know, right? No, what can I use? Unknown variable. Is x. Okay. Them each 2 more stickers. So each person, what do we do? How many more? How many more did I give you? Each 2 more. So I gave you 2 more, you 2 more, you 2 more, you 2. I gave everybody how many more? 2. So how do we represent 2 more? How do we represent that? Just in a regular math equation. 2 more would be what? Plus 2. So I'm trying to break it down, and then I'm going to let you guys see if you can work it out. Altogether, she gave him a total of 30 stickers. Use a tape diagram to show the number of stickers she originally gave each volunteer. Okay? So let me at least have you guys do this. Draw the tape diagram and draw, let me see how many boxes you have. Draw the number of boxes. Yes, Mom? Just draw the boxes first, and then you can go, okay? It'll take you a minute. Oh, okay. Yes, no, that one's not right. How many volunteers do we have? No, look what it says. How many volunteers do we have? 10. I don't think it says 10 right there.
I said 2.
Huh?
I said 2.
No, I don't know where you got the 2 from. That's stickers, 2 stickers. How many volunteers? Draw the box and you can go, but go quickly so we can get. It's good. That's good, Bella. Just finish the box out. Okay? You're good. Go quickly and then come back so we can finish this up. Okay? Chase, you know how many boxes we should have? Chase says we should have 5. What do you think, Chanel? Why is it 5?
Because there's 5 volunteers.
Okay, Chase and Chanel said we need 5 boxes because there are 5 volunteers. I'm good with that. So I'm going to go 1, 2, 3, 4, 5. Okay? So there's 5 boxes because there's 5 people, right? 5 volunteers. Chase, what's the total? Okay. What in each box? How many did the first person get? We get the same number, which we don't know. May gave them how many more? 2 more. How do we represent that? We know it's a certain amount, and then he gave them 2 more. How do we write that? Eat. Right? So Eden thinks it's x plus 2 because they get the same number of stickers, which we don't know, and then they gave them 2 more. Okay? What do I write in the second box, Eden? You just did the hard part. This is the easy part now. You just did the hard part. What's in the second box? The same number. X plus 2. Right? Eden, this is a trick question. What's in the third box? What's the third box? It's not a trick question. It's the same number of stickers and 2 more, right? So what's here? Eden, you need help? What is it then? X plus 2. What's the next one? X plus 2. What's the next one? X plus 2. That's it. That's it. Now I have to figure out what X is. Because X is the original amount. Look, she originally gave them, this is what I'm looking for, and then this is going to be the same thing. Okay? Right? So, hey, Kenny, how can I write it algebraically? Oh, do I need like this? 5. How do I write it? This is how many times? How many times we do it? So 5's got to be times the x and the 2, right? Is that right, guys? Chase. This is 5. So 5 has to be times the x and 5 has to be times the 2. What property do we learn that? When do we put the parentheses? On what property? Distributive. Okay? So what am I putting inside parentheses? X plus 2. What does it equal? Oh, we got that now. X plus 2 how many times? 5. Chase. How's up? So this is x plus 2, which is right here. How many times? Put it inside parentheses in one term. Okay? What is it? What does this equal? No, what does it equal? We know it's 5 times x plus 2. What does it equal? Mariah, you got the answer? No, I don't. Listen, guys, we don't need a calculator right now. What does that equal? Look at the word problem. Look at the word problem. What do you have, Mariah? That equals what? Chase just said it. Look, guys, right here. All these x plus 2s, 5x plus 2 equals 30.
Your
Right?
total's going to go on the right side of the equal
Okay.
sign for now. I mean, it doesn't always go right, but for now.
So what I want you to do is, Mr. Park's stopping right here. What I'm going to do is I'm going to draw this right here because we got to do this, and we did this on our last test, so I'm assuming we're all good at it. Please try to figure this out. We'll distribute it out, and then we'll solve for x. Okay, I'm going to come around and help you if you need some help. But this is, you guys all have to do this yourself. If you need some help, raise your hand. Yes. Now you have to solve for x. How do we do that? Yes, that's right. 5 times x is 5x. Okay, equals what? Keep this right there, dude. Right there, right? Good. Now we have to solve for x. Remember what we did here and what we did here, okay? The first thing we did add or subtract, and the next one we multiply or divide, okay? Does that make sense, Chase? What do you got, Kim?
Here's what you're thinking. This
see?
is like a scale.
Let's see. Yes, good. What do you do? No. Remember, what I need to do is I need to keep the x is last. Anything that's touching the x is last. What's not touching the x? I want you to do that first. Balance it out. You're looking good? There you go. 10 minus 10 is what? Yeah. Okay. So 5x equals 20. Okay, figure that out. You should know. What's 5 times x? Write it down. What's 5 times 2? If you don't know, do it in the calculator. Let's get this one done. Bella, it's okay. I'll sign you in. Let's hurry up and write this down, okay? Let's write down what's on the board. Equals what? We didn't touch that, so just drop it down. Please drop all that down. Okay, what do we do next now? There's a plus, right? That plus. We need to make sure we're not losing that. What do we do next? Listen, I need the x by itself. So anything not touching the x is what I'm doing first. Which one am I touching first? Which number am I going to address first? The 5x or the 10? Okay, the 10. So what is that? How do I get rid of that 10?
Subtract.
Okay, do it. That's right. Subtract what? Opposite. What's the opposite of adding 10? Chanel, look at me. What's the opposite of adding 10? You just said it.
Oh, subtract.
Yeah, subtract what? Subtract what? Chanel, give me a second, okay? The opposite of adding 10 is subtracting what? Subtracting the same number. Look. Adding 10, subtracting, they're opposites. Okay? Adding 5, what's opposite of adding 5? Minus what? Minus 5. Look, we did it right here several times. Look, 9, positive 9. Opposite of positive 9, minus 9. Right? What's opposite of plus 23? Minus 23. Subtracting 23. So what do we do here? Write it right underneath it. What's the opposite of adding 10? We just said, yes, please write it underneath that, underneath the 10. Yes. If I do it on this side, what do I have to do on the other side? We have to do the same thing, Chanel. If I subtract the 10 here, I've got to balance it out. It's got to balance the same way. So if I take 10 away from here, what do I have to take away on this side? 10, the same thing. We're doing the same thing. Okay? Take 10 away from there. Just put minus 10 under it, Chanel. That's it. What's 30 minus 10? Down 20. Equals. Drop the equal sign. What is 10 minus 10? Chanel, look at it. The opposite always equals 0. Okay? You don't even need to think about it. If it's the opposite, it's always equals 0 when we're adding and subtracting. So those are 0 pairs. So what is it going to equal? 0. So I don't even have to write it down, right? What did I not touch over here? Drop the 5x down. Now we got to do the same thing. What's the opposite of what is going on here? I got to get. What are you doing? Are you adding 5 there? You adding 5 to the x? We got to do the opposite of what's going on to that x. 5 and the x are being what? What operation is being used? You told me a while ago when I was at the board. No, that's not subtraction. That's 5 times x. Right? What does this mean, Chanel? 5 times x. What's opposite multiplying by 5? What's opposite of multiplying? By the same number. Divided by the same number again now. What do we divide by now? Instead of multiplying by 5, what am I going to divide by what? Divide that by 5. 5 divided by 5, and you figure it out. If you do it to one side, you have to do it to the other. What's your answer? Kenny, this is like 5 classes in a row that you're going. I mean, it is. I'm just telling you a fact. Okay? It is. I can't let you go every day during this class. You don't have a restroom accommodation. Does that make sense? If you have restroom accommodation, I understand, but we can't go every class period. Every class. Wait till we get started on this work. I'll let you go. Okay? Give me a good job, Chad. Get it, Mariah? What's 20 divided by 5? Write it down. I don't know. Okay, Bella, I'm going to do it right now. Hey, guys, let's take a look right here. Let me go through real quick. Walk me through it real quick, Kenny, so you go to the restroom then. What do we have? X, 5 times 2, 30. Next. First. Subtracting 10. What do I do next? I do it to the other side. Okay? What do we have here? So those will cancel out. 20 minus 30 minus 10 is what? 20. Now, I didn't touch that, so I'm going to drop that. Now, hey, what's going on right here? I'm multiplying the 5 and the x, right? Yeah, so we do the opposite. And Kenny said that dividing by x equals 4. Okay? So each person got how many stickers? 4 plus 2, right? The original amount was 4, and then they gave each person 2 more, so they got 6. Okay? Hey guys, please take a look at about 15 minutes left. Can you get your worksheet out? Let's grab that next worksheet out, guys. Here's the second worksheet. Okay? It's the tape diagrams. Okay? I'm going to let you get into groups, and I'm going to come help you. Let's get into groups of 3 and 3. Okay? So find 2 other people. and then we'll read it, and then, look, it says explain your reasoning and then your solution. There's your tape diagram right there. Do you agree or disagree? Okay? Let's go. I'm going to give you about 10 minutes to work, guys. Let's go. I'm going to come watch you. We got to go quick, though. Everybody get in a group of 3. Get in a group of 3. Quickly, Kenny. Kenny, I'm sorry, but I can't let you go tomorrow, okay? This is like 4 or 5 days in a row for you. And I don't want to prevent you guys from going to the restroom, but we can't do it every day. What's up, Eden? You guys just want to read the first one? I'm going to let you work on it, okay? It says, decide if the tape diagram matches the scenario. Explain why you agree or disagree. If you disagree, draw a new diagram. Lastly, use a tape diagram to answer the question. So, if we agree, write agree. If we disagree, what is it saying? To draw another tape diagram, okay? Eden, Kenny, I need you guys working. Or Eden, Chase, I'm sorry. It says, Marisol is cutting a 13-foot piece of ribbon. Did you look, Bella? For a craft project. She cuts off 5 feet and then cuts off the remaining piece into 4 equal lengths of X feet each. How many feet long are each of the remaining pieces? Okay? So see if that's the right tape diagram. And then write if you agree or disagree. If it's the right one, circle it, explain it. And if it's wrong, you have to do a new tape diagram. Okay? So I'm going to read it to you, Chase, okay? Yeah. It says, decide if the tape diagram matches the scenario. Explain why you agree or disagree. If you disagree, draw a new diagram. Lastly, use the tape diagram to answer the question. So if we agree, we're going to say that we're going to show the reasoning, we're going to show the equation and say we agree. If we disagree, it says draw a new tape diagram, okay? Here we go. This is Marisol is cutting a 13-foot piece of ribbon for a craft project. She cuts off 5 feet and then cuts the remaining piece into 4 equal lengths. Eden, dude, how are you going to do this if you're not looking? Come on. How many feet long are each of the remaining pieces? Okay? So according to what we've been doing, is the total right? Is it broken up into the right number of parts? Okay? We figure that out and then find the solution for it. Okay? Chase, as opposed to drawing a tape diagram, I would see if that's right or wrong first, okay? And write if you agree or disagree. Because you don't have to draw the tape diagram if you agree, if it's right? I mean, that will be the tape diagram, okay? So just see if it's right or wrong. That's what you guys have to work out right now. We have nothing written over here. Huh? Nobody's written anything down. Let's go, girls. Is this difficult? Chanel, is it difficult? Kinda. How about you, Bella? Let's try our best, guys. You want me to help you with the first one? Yes? Bella, let's take a look, okay? Sticky right there. Need a little clean. So, it says, what is the total length of the ribbon? You guys have to help me though. I can't do, what's the total length of the ribbon?
13 foot.
13 foot. 13 feet. Is that total 13 feet? Look at that tape diagram. Is 13 correct? Yes? So we know that that's correct, right? Okay? So it says she cuts off 5 feet. Did she cut off 5 feet somewhere? Is there 5 feet on that ribbon? Is that right? Is that right? And then the remaining, there's 4 other equal parts. So 4 parts of X. Is that correct? Right, you have to look. The 4 parts of X. Is that right, Bella? So look, the diagram looks correct then, right? So now we have to figure out, okay, if we agree, let's circle agree. Let's circle agree. Oh, Bella, you already got agree. Good. So how many feet long are the remaining pieces? So let's look over here where it says explain your reasoning. How many X's do I have?
4.
4X. So let's write it down. I'm going to write 4X, right? Am I adding the 5? Am I subtracting that 5 to the 4X? Am I dividing the 5 or am I multiplying the 5? What am I doing with this 5? 4X. What did you say? Adding. All of this we're adding together, right? 4X plus 5. What does it equal, Bella? What's the total? What's the total? What's the total?
13.
Equals 13. There's my equation right there. So 4X plus 5 equals 13. Now solve for that. You guys work together and solve that, okay? So let me write that for you. Yes. What was that? All right, you guys go ahead and solve it for me, okay? Please solve it for me. You guys have to solve it as a group. You guys got it?
Yeah.
I'm like 90% sure. Let me get it.
90% sure what?
So I don't kind of. So if we agreed, we write the like this.
You just solve it. If you agree, you just solve it like this.
Okay.
But if you disagree, you make a new diagram and then solve it.
Oh, okay.
So look at that first one, guys. We don't have time. Let's look at this first one. So it says it's a 13-foot piece of ribbon. Is it 13 feet in total? Kenny's got it. Kenny's got it. Well, no, that's not 5X. How many X's are there? There you go. So how many X's do we have? Eden, how many X's do we have? 4X. So I would write 4X, right? And what are they doing with that 5? Are they adding it, subtracting it, dividing it, multiplying? What are they doing? They're adding it. 4X plus 5, right? Equals what? What's the total?
Equals 13.
Okay, please solve it now. Please solve that, guys. Okay? Solve that for me. Hey guys, we got to at least finish this one problem, okay? We have to at least finish this one problem. We have 2 minutes. We have 2 minutes. Come on, girls. You haven't done anything past when I left. You're still there. Okay? We can solve it. Kenny, you guys get it? Girls, turn around. Everyone, girls, back to your seat. Girls, back to your seat. Come here. I'm going to do it on the board for you. Help you. Hurry up. We have like a minute or two, so we got to go quick. What do we have? 4X plus 5 equals 13. Is that right? So, Mariah, what's the first thing I have to do here? If it's something's touching the X, don't worry about the X. What is the first thing I have to do? To get rid of the plus 5. How do I get rid of the plus 5? What's the opposite of plus 5? Subtract 5. But on this side, I have to do it on the other side, right? Is that right? What do I do here, Mariah? Subtract. Those 13 minus 5. Please let me know. 8. Good. Equals. I didn't touch it, so I'm going to drop it down. What's the next operation now? I got to get the X by itself. I'm not adding here. What am I doing here when they're next to each other? I'm always doing the opposite operation. What am I doing here when a 4 is next to the X? I'm multiplying. So what's the opposite of multiplying? So I'm multiplying by 4, so what's the opposite of it? By what? Dividing by 4. Good. How about on this side? Got to balance out. Divide by 4. So those cancel out. 4 over 4 is 1, so they cancel. So I'm going to drop the X down. What's 8 over 4? Kenny, Eden, Chase, I hope you guys have the answer. What's 8 over 4? Dude, hey, if you don't know it, find it. Work it out. Bella, I need you working, okay? You can't keep watching, Bella. You got to work. X equals 2. Okay. Hey, guys, listen. Hey, back to our seats, back to our seats. Hey, I need you to do one of these for homework. Okay? I need you to finish as much as this. Chase. You hear what I just said? All right. I need you to do this for homework. At least one. All right? Come back with one tomorrow, so this will be our homework for tonight. Hey, guys, listen. A lot of this stuff is not as easy as it used to be, so we got to have to concentrate.